Hello, good morning students. Welcome in SBIT online classes. I am Rampal Prajapat from Electrical Department. Dear students, in our today class, we will discuss on power system first, part 28. And for today class, our topic is SF6 circuit breaker and vacuum circuit breaker. So in this class, we will discuss about the construction and working of a SF6 circuit breaker, advantage, disadvantage of SF6 circuit breaker, and similarly for vacuum circuit breaker. So in our today class, we start from SF6 circuit breaker first. We know that in SF6 circuit breaker, insulating medium or arc quenching medium is SF6 gas. SF6 gas has the following properties due to which it is used in SF6 circuit breaker. First is, it is a colorless, odorless and non-toxic and non-inflammable gas. Means this gas has no color, no odor, and non-toxic and non-inflammable. Second is, it is extremely stable and inert, and its density is 5 times that of air. Means this gas is stable at high temperature and pressure, and also inert with its density greater than air and oil insulating medium. Next property is, it has high thermal conductivity. It means it does not provide a conducting path at lower temperature. Means at higher temperature, which is more than 500 degrees Celsius, it behaves as a insulating medium below this temperature. Next property is, it has high electronegativity. What is the mean of electronegativity? It means this gas has the property of electronegativity, means it can absorb the ionized particles of gases or air between the contact gap of a circuit breaker. So this property is known as electronegativity. Next property is, it is chemically stable up to 500 degrees Celsius. It means it does not react with any chemical at below 500 degrees Celsius. And last is, it has high dielectric strength. Its dielectric strength is higher than air and oil, due to which it provides better insulating medium between the contact gap of a circuit breaker. So now, construction of a SF6 circuit breaker. Construction of SF6 circuit breaker consists of two parts mainly. So first part is interrupter unit and second part is gas system. So in first part or in interrupter unit consists of fixed contact which comprise a set of current carrying fingers and an arcing probe. So when the breaker is in the closed position, fingers make contact around the circumference of the moving contact, which has the arcing probe enclosed within its hollow end. So these contacts are surrounded by interrupting nozzles and a blast shield, which controls arc displacement and movement of the hot gases. So the moving contact is in the form of hollow nozzle sliding in a second set of spring-loaded fingers. Side vent in the moving contact allow the high pressure gas into the main tank. So, as soon as the moving contact is withdrawn from the fixed finger contacts, an arc is drawn between the moving nozzle and the arcing probe. As the contacts move further apart, the arc is extended and attenuated, so it is the finally extinguished by the gas flow from the high pressure to the low pressure system. So the figure consists of interrupter unit of a SF6 circuit breaker in which there are two contacts. One is a fixed contact and second is a moving contact. So this is moving contact and this is moving contact, and gas system is provided here through a nozzle and fixed contact are fixed at its position. Moving contact has the property of movement, means it can move from its position. So in interrupter unit, moving contact and fixed contact comprising a set of current carrying fingers and arcing probe. In closed position of the breaker, the finger make contact around the circumference of the moving contact, having the arcing probe enclosed within its hollow end. The contacts are surrounded by the interrupting nozzles and blast shield to control the displacement and the movement of the hot gas. So the moving contact is in the form of hollow nozzle. It slides in a second set of spring-loaded fingers. Side vent in the moving contact permit the high pressure gas into the main tank. So this high pressure provides insulating medium. So when the moving contact is withdrawn from the fixed finger contact, an arc is struck between the moving nozzle and the arcing probe. So with increasing the separation between the contacts, arc is extended and arc is attenuated, and it is final extinguished by the flow of gas from the high pressure to the low pressure system. This is the basic working of this interrupter unit. Now next system in SF circuit breaker is gas system. The gas system, which is a closed circuit gas system which is used in SF6 circuit breaker. So the low and high pressure system are fitted with low pressure alarm and a set of low out switches which give a warning the moment the gas pressure drops below a certain value, because otherwise there will be a reduction in the dielectric strength and arc quenching ability of the breaker is endangered. If the danger limit is reached, the safety device immobilize the breaker. So the overriding safety devices see to it that a fault in the control circuit does not permit the compressor to build up excessive pressure in the high pressure reservoirs or continue to pump gas into the atmosphere in the event of major leak. So the gas is stored in the high pressure chamber at 16 atmospheric pressure or 16 ATP, whereas gas pressure on the low pressure side is 3 ATP. The temperature is 20 degrees Celsius. In order to prevent liquefaction of the gas in the high pressure chamber at low temperature, a heater is fitted in the high pressure chamber. A thermostat is set to switch on when the ambient temperature falls below 16 degrees Celsius. So the figure consists of gas system of a circuit breaker. So In the gas system, there are two filters and is a heater which maintain the temperature or to maintain the gas in liquid form. These are the service connections and relay valve, next filter and a compressor. This compressor compresses the gas to form it in a liquid form. It converts the gas into liquid form, and there are alarm system for HP. Alarm system provides alarm signal when the pressure of the gas is less. So there are different types of alarm system: LP, HP, LP lockout and low temperature alarm. So this is the simple gas system of a SF6 circuit breaker. So in gas system, SF6 gas system is employed in SF6 circuit breaker. Since the gas is costly, it is reconditioned and reclaimed after each operation of the breaker. Necessarily, auxiliary system is provided for such purposes. The low and high pressure system are provided with low pressure alarm and set of lockout switches which give a warning. The moment of gas pressure drops below a certain value, failing which dielectric strength will be reduced and arc quenching ability of the circuit breaker will be endangered. On reaching danger limit, the safety device immobilizes the breaker and the gas is stored in the high pressure chamber at 16 atp. Now the advantage of SF6 circuit breakers are, these are the following advantages of SF6 circuit breaker. First is the current chopping tendency is minimized by using the SF6 gas at low pressure and low velocity. Second is the closed circuit gas cycle and low velocity operation eliminates the moisture problem and give noiseless operation of the breaker. Third is because of the outstanding arc quenching property of SF6, the arcing time is small and therefore contact erosion is less. Means SF6 gas does not create erosion at the contacts of the circuit breaker. Its arcing time is less. Quenching provides in less time. Next is no carbon particle is formed during arcing and therefore there is no reduction in the dielectric strength of the gas. Next is the circuit breaker performance is not affected due to the atmospheric conditions. And last is electrical clearance are drastically reduced due to high dielectric strength of SF6 gas. So these are the advantage of SF6 gas. Basically, advantage of SF6 circuit breaker depends on the advantage of SF6 gas, because SF6 gas has high dielectric strength, electronegativity property, high thermal conductivity, high dielectric strength. So due to which SF6 circuit breakers are used in high voltage circuits. Now next circuit breaker is vacuum circuit breaker. What is vacuum? Vacuum means no medium. So in this case we eliminate medium between the contact gap of the circuit breakers. Now the construction of vacuum circuit breaker is very simple, and compared to air or oil circuit breakers, its outer envelope is normally made of glass due to the easy of joining it to the metallic end caps. and also because the glass envelope makes it easy to examine from outside the state of the contacts after the breaker has interrupted the current. So this is important since a change from a silvery mirror like finish to a milky white color shows that the vessel is losing its vacuum. A sputter, a sputter shield is provided in between the contacts and the envelope in order to prevent the metal vapor reaching the envelope as it reduces the breakdown strength between the contacts. So this is generally made of stainless steel. Inside the sputter shield, the breaker has two contacts. One is fixed contact and second is moving contact. So the basic circuit diagram or figure of a vacuum circuit breaker is shown here. Basically there are two contacts. One is fixed contact and second is moving contact. And the whole portion is covered in a ceramic envelope. So this is the fixed contact and contact rings, sputter shield, bellows and moving contact. Bellows are provided to move the or to provide the movement of moving contact of the circuit breaker and also eliminate the other medium inside the circuit breaker contacts. Sputter shield is provided to maintain vacuum between the contact gaps. So move that a short distance of 5 to 10 mm depending upon the operating voltage. Means contact of circuit breaker move a short distance of 5 to 10 mm which depends upon the operating voltage. The metallic bellows which are made of stainless steel is used to move the lower contact. So the design of the bellows is very important as the life of the vacuum circuit breaker depends upon the ability of this part to perform repeated operation satisfactorily. So the periphery of end cap is sealed to envelope and the fixed contact stump is an integral part of one end cap. One end of the fixed as well as moving contact is brought out of the chamber for external connections. Means external connections are provided to the contacts. Now advantage of vacuum circuit breakers are basically vacuum circuit breaker is self-contained and does not require filling of oil and gas. They do not need auxiliary air system, oil handling system, etc. Next, rapid recovery of very high dielectric strength on current interruption so that only half cycle or less arcing occur after proper contact separation. Next advantage is current interruption occur at the first current zero after contact separation with no restriking, make it exceptionally good for capacitor and cable switching and long line dropping. Next advantage is very high power frequency and impulse withstand voltage with small contact spacing, allowing easy of accretion and timing. It means in a vacuum circuit breaker Contact of the circuit breakers are moved only with a small distance, which may cause high insulating medium or infinite resistance between the contact gaps, which eliminate the arcing. Next is no emission of gases and it is pollution free. Next, no explosive and silent operation. Next is breaker unit is compact and self-contained. It can be installed at any required orientation, maybe horizontal or vertical. Next is large number of operations on load or short circuit suitable for repeated operating duty long life. Next is unable on any voltage, usable on any voltage up to 230 kV and higher, where exceptionally long life and maintenance free operation is desired. Means it does not require maintenance. Next is there are no gas decomposition products in vacuum and hermetically sealed vacuum interrupter keeps out all environmental effects. And next is constant contact resistance. In vacuum, the contact cannot oxidize. Therefore, their very small resistance is maintained throughout their life. Next is high total current switched because of small erosion of contact piece. Rated normal current can be interrupted up to 30,000 times and rated short circuit current rupturing current can average 100 times. Shortly we can say that advantage of vacuum circuit breakers are high insulating medium, means there is no insulating medium between the contacts of the circuit breaker required. So small distance between the contacts may cause infinite resistance. Second is it is noise free operation. Next is no pollution. Next is there is no erosion at the contacts of the circuit breaker because there is no medium between the contact gap of the circuit breakers. So these are the basic advantage of vacuum circuit breaker. So dear student, in today's class we have discussed SF6 circuit breaker, construction of SF6 circuit breaker, working of SF6 circuit breaker, properties of SF6 gas, advantage of SF6 circuit breaker. Similarly, vacuum circuit breaker, working of vacuum circuit breaker, construction of vacuum circuit breaker, advantage of vacuum circuit breakers. These all things have been discussed in this class. So thank you for today's class.